All right. And so now, once we've learned about finding z-score of a data value in any data set, as a brief reminder, z-score for any data value is found by the value in the data minus the mean divided by the standard deviation. And then another reminder is that every value has a z-score. And so in that way, now I'm going to show you how to use a z-score as an alternative method to find outliers in your data. So this method I'm about to show here, based on this particular scheme here, that so once everybody agree that every value in the data has a z-score, and we have seen throughout our examples that so in that way z-score can be negative, and z-score for a value can be positive depending on whether the data value is above the mean or below the mean. And so now in this method we're going to rely on a scale over here. Let's say this scale is the scale of all z-score. So z-score 0 at this point is indicating that so this scale is where we put all z-scores. And then back to what I was about to say earlier, z-score 0 was indicating some value is right on the mean. And so now in the data, those values having z-score from -2 to 2. I'm drawing my interval a little bit not as. So let me repeat. So in a data set, those data values having z-score anywhere from -2 to 2, those are what I so call the usual values. The usual values, meaning there are nothing special about those data values. But then in your data, if any data values having z-score falling outside of that, so you have either going above a z-score 2 or having any data value with a z-score below -2, those two red zones right there are considered as the unusual values. And so later on throughout the quarter, and when we start getting into somewhere about middle of the quarter, I will get back to this and explain the reason why this method came out here. But for now, we take this as a method, and then you will learn the solid reasoning of why it was chosen in somewhere in the middle of the quarter, where you have seen enough and have learned enough experience working on stats. So let's immediately use this method right here to find data. Now, so I'm going to come up with an example. And in my example here, let's find outliers, again, of data 1. So I have to clarify that some of you at this point, when you're watching this video, you might wonder, we already found the same data set. And let me quickly turn back into my screen here. But so here's my data 1. The same exact data set on the same data sheet. Here, we already found the outliers, didn't we? I agree. But that method we've done previously in a different video was relying on the box plot and using the quartiles number. But this method here, we are going to be using z-scores. And so, but there are a couple of similarities that exist here. So the idea about the lower limits and the upper limits come back again. Because in the end, what we need here is that we need to recognize a certain boundaries, a certain limits, so that any values in the data is still being contained inside of that. Those are the usual values, and being outside of that, those are the unusual values. And by the way, so at this point, I need to clarify, unusual values is a different ways of calling those outliers, because they are unusually high or unusually low values. So here's the thing. Before I rush into introducing the low limits and the up limits, how about let's do a quick calculating. It makes sense, but this is only scratch work. It makes sense that anytime we're looking for unusual values or the outliers, they tend to be those either extremely too high values or extremely too low values. So immediately seeing this scheme, this criteria to detect outliers, somebody can quickly think that, hey, 124 in our data 1, the z-score for that, I'm going to take 124, subtract 76.3. And so another reminder that our data 1 has that mean value 76.3 and the standard deviation being 12.5. And so 124, take away 76.3 and dividing that by a 12.5. My z-score for 124 is being a 3.82. So this is indicating that 124 is well qualifying to be an outlier, because the z-score we just calculated here falls outside of the usual range of the z-score. It's falling into the unusual area, being so it's indicating that 124 in this data is unusually high. But then think of that method right here, then that means we have to search through every single value in the data and calculate z-score just to detect who's outside of the limits and who's inside, which is not a good plan. And so that's why we are coming back to what I was halfway introducing earlier, that we're going to come up with a low limit and an up limit again. The idea now is that, so the low limit is an actual or some value in the data that corresponds to a z-score -2. And the up limit is the value relative to the data that corresponds to the z-score +2. And so in that way, I am going to go from the mean value. And general rule for that is to find lower limits, we're going to go mean value subtract 2 times of the standard deviation. And then the upper limit is from where the mean value is. We're going to add 2 times of the standard deviation. And so that means in our data 1, low limit is going to be 76.3 minus 2 times the standard deviation, 12.5. And the upper limit is giving me from where 76.3 is, I am going to add 2 times of the 12.5. And so in that way, concluding that my low limits here is going to be equals to 51.3. And the up limit I found through the calculation to be 101.3. And if any of you worry about these limits or not in the data, of course there shouldn't have to be. I'm not expecting these data to be, these values or to be from the data. They're only having values that's relative to the data. But in the end, they are acting as the limits, some kind of boundary to decide which one or who in the data qualify to be outliers and who are still inside of the limits. And so now the answer is becoming clear. If we now look through the entire data 1, which is here, then 60, the lowest value, is still completely contained inside the lower limits. And up to 96 here, it's still being contained exactly inside the limits as well. So any of those values in data 1 from anywhere from 60 to 96, those are completely contained inside our up limits and low limits. And we have 104 and 124 falling outside of those limits right there. And so now our conclusion here is that the outliers we found here, or once again, those are 124 and 104. And so before I end the discussion on this kind of problem using z-score to find outliers, let's make a quick comparison right here for you to understand the difference. Comparison of results we've found. But so now if we're staying with the z-score method to find outliers, and then what we've learned before z-score, we've learned using the Q number. Those are quartile numbers. That's what I call the Q numbers, using the Q numbers. Then using the Q numbers, if you remember and recall from other videos I've shown you, then the low limits was 50, and upper limits to find outliers was 98. However, in the using the z-score method, we came to low limits being 51.3 and upper limits being 101.3. So they are slightly different. So the two methods giving slightly different results. So in using the Q numbers method that we've learned previously, we did end up with outliers being 104 and 124. And using the z-scores methods, we still ended up with 104 and 124. But due to the nature that being slightly different in terms of coming up with the two boundary, the two limits right here, then in some other problems, we might end up with slightly different results. But that is completely okay. If there's that question brought up about, so which method is better for finding outliers? It's not really a concern about which method's better, but it's more about which methods work better in which situation. And so I would say using the z-score to find outliers works better if you're on a bell curve. That those normal distribution shapes that I briefly introduced before. Using the Q numbers methods is going to work better if you're on a skewed distribution. And formally speaking, I haven't had a proof for this result, but due to my own experience working with a lot of stats, then I found out that the Q number, using the Q numbers, it tend to work better when your data is on a skewed distribution. And so at the conclusion of our discussion on using z-score as a way to detect outliers, then the two primary formulas we are using here are the lower limits needs to be from where the mean is minus 2 times the standard deviation of your data. And the upper limit is found by the mean value plus 2 times the standard deviation of the data.